One of the first things and almost the building blocks of foundation for what, when calculus was invented, was the idea of limits. Limits are what happen when we take the input value of a function and slowly approach it. Let me give you an example. Let us say f of x is equal to x minus 3 over x minus 3. You might be tempted to say this is equal to 1 because we have the same thing in the numerator divided by the same thing in the denominator. And to that I would say that's almost true. But unfortunately, f of x is not defined when x is equal to 3. We have a 0 divided by 0. Any number divided by 0 is undefined. You can't divide anything by 0. Let me draw a sad face. We're sad. We're sad. We don't know what this function is when it's defined at 3. However, or I guess when x equals 3, that's where our limit expressions come in. We can say, well, actually, first let me draw a poorly drawn graph of this to really visualize what I'm talking about. Take my black marker, drag it across. This is f of x. As you can see, when x equals 3, we have this little hole here because we don't know what it's defined as. Now our limit expressions can come into play. We can say, let me write this down. I guess you don't need to write that. You can just say the limit of f of x as x approaches 3. What is this equal to? Well, let's take a look at the graph itself. When we take numbers that are less than 3 and approach from the left side, we can see we have 2.9, 2.9999, 2.999 with a million nines after it. We approach 1, and the same thing is for the other side. We approach from numbers that are larger than 3 from the right-hand side, 3.1, 3.01, 3.000001. It all approaches 1. So this would be 1. We would say the limit of f of x as x approaches 3 equals 1. Let me give you another example. This time, I'm thinking of doing a piecewise function. But my little piecewise function shall have a twist to it. Let's use pink. Let's say h of x is equal to, well, it's equal to x squared. No, I disagree. 3x. But not when x equals 1. No, not when x equals 1. But for 1, x is equal to, here's our piecewise function. Let me display this on a graph for you. What should I use? Let's use this. Actually, I don't want the cross graph. here's what the graph would look like. When x is equal to 1, it is not equal to our original function of 3x. Instead, it is equal to 1, right here. But what's the limit as it approaches this anyway? When we have this straight graph, what are we approaching? Think of it like approaching this little hole here. We can write this type of equation again. The limit of h of x as x approaches 1. What does it approach? Well, when we get to values that are greater than 1, 1.1, 1.01, 1.00001, it approaches 3. And the same thing can be said for this side. Just visually looking at this graph, it approaches 1. When we get to 0.9, 0.99999, it approaches 3. So we can say that the limit of h of x as x approaches 1 equals 3. This is just the very basic introduction of limits. Next video, I don't know what I'm doing next video.